Good morning. This is P. Anand Reddy, a senior lecturer in mathematics. Today we are going to discuss basic engineering mathematics. The topic is matrices. In these matrices, previously we have discussed the definition of matrices, types of matrices, transpose of a matrix. With the help of transpose of a matrix, symmetric, skew symmetric, and determinant we have discussed in the last class. So here, in this today we are going to discuss singular matrices, non-singular matrices, and adjoint of a matrix. So after completion of this period, you would able to find you would able to define this singular matrix and non-singular matrices, and how to find the adjoint of a matrix. Just once we recap uh, before going to this, what is the matrix? Matrix is a rectangular array of numbers in rows and columns. So in generally matrices are denoted by capital letters and numbers are called elements. They are denoted by small letters. Now in this types of matrix based on the order of a matrix. Order is the number of rows and number of columns is the order of the matrix. Based on that, we have classified the matrices. A rectangular matrix if number of rows are different from number of columns. Square matrix if number of rows are equal to number of columns. Row matrix if the matrix having only one row. Column matrix if the matrix having only one column. Diagonal matrix if all the elements are zeros except diagonal elements, principal diagonal elements. Scalar matrix all the elements are zeros and principal diagonal elements are equal to constant. Unit matrix all the principal diagonal elements are unit and other elements are zeros. Null matrix if all the elements of A are zeros, then that called null matrix. So the afterwards, transpose of a matrix. The transpose of a matrix means it is our transpose of a matrix is a matrix which is obtained by interchanging its rows and columns. It is denoted by A transpose. Based on the transpose of a matrix, we can define the symmetric matrix. A square matrix capital A is said to be symmetric if its a transpose equal to A itself. Skew symmetric matrix. A square matrix capital A is said to be skew symmetric if A transpose equal to minus A. Now, determinant of a matrix. The determinant of a matrix is with the help of minors and cofactors we can define the determinant of a matrix. Minor of an element is the determinant of a matrix which is obtained by deleting that row and column. Now, cofactor is the minor is multiplied by minus 1 power I plus j, where I and j are I is the ith row and jth column element. Now, determinant of a matrix. Determinant of a matrix is the sum of the products of any row or any column with their corresponding cofactors. Now, with the help of that definition, we have to find the determinant. If A is equal to 4 minus 2 minus 6, 3, then what is the determinant of A? Determinant of A is equal to, it is a 2 by 2 matrix. So, the determinant of A is AD minus BC. Determinant is 12 minus 12, it is 0. Now, we can see the one more example. If A is equal to 1 2 1 3 2 2 1 1 2, then what is the determinant? Determinant of A is equal to, with the help of first row elements I am expanding using Laplace expansion, 1 into AD minus BC, determinant of 2 2 1 2, that is 2 into 2 4 minus 2 into second element is actually plus 2, minus is the cofactor term, minus 2 into AD 6 minus 2 plus 1 into 3 minus 2. This after simplification you can get it as minus 5. See, in this case we got one determinant is 0 and another determinant is non-zero. Now once you recall cofactors, if A is equal to 1 2 1, 3 2 4, 1 1 2, then what is the cofactor of 3? Cofactor of 3 is, cofactor means it is the minus 1 power I plus j into determinant of the matrix, which is obtained by deleting that row and column. So here 3 is the second row first column. After deleting second row and first column, we can get a matrix that is 2 1 1 2. Its determinant is multiplied by minus 1 power I plus j. Here I is 2, j is 1. Therefore the cofactor is equal to minus 1 power 2 plus 1 into determinant of 2 1 1 2. This is minus of 2 1 is 4 minus 1. 4 minus 1, this is 3, and minus minus 3. In this same matrix, what is the cofactor of the element 4? Here 4 location is second or third column. So the cofactor of this one is, cofactor of 4 is minus 1 power 2 plus 3 into determinant of, after deleting second or third column, 1 2 1 1. Now AD minus BC, AD is 1 1, BC is 2 2 1. So minus 1 power 5 into 1 minus 2, that is minus of minus 1, that equal to 1. Now how do you find the transpose of a given matrix? Transpose of a matrix is by interchanging its rows and columns. If A is equal to 1 4 5 2 2 3 3 1 0, then what is its a transpose? Transpose is by interchanging rows and columns. A transpose equal to, first row is 1 2 5 1 4 5, so it will become a column 1 4 5. 2 2 3, it will become a column, second column 2 2 3, and 3 1 0 will become a third column. So its result is 1 2 3 4 2 1 5 3 0. Now singular matrix. A square matrix capital A is said to be singular if its determinant equal to 0. That is, if the determinant of a square matrix is 0, then it is called the singular matrix. For example, already we have seen the first example. If A is equal to 4 minus 2 minus 6, 3, then what is the determinant of this one? Determinant of this is 12 minus 12, it is 0. So A is a singular matrix. Similarly, if you want to find this one more example, A is equal to 1 2 3 4 5 6 7 8 9. Then what is the determinant of this matrix? By expanding with the help of first row, 1 into AD minus BC 45 minus 48 minus 2 into, after deleting second row, the first row second column, 4 6 7 8 7 9, so determinant is 36 minus 42, plus 3 into, after deleting first row and third column, the determinant of the matrix 4 5 7 8, its determinant is 32 minus 38 35. Minus 3 plus 12 minus 9, this is also 0. Therefore A is a singular matrix. So what is a singular matrix? Singular matrix is, if the determinant of A is 0, then A is called singular matrix. A square matrix capital A is said to be singular if its determinant is 0. Next, non-singular. If a square matrix capital A is said to be non-singular if its determinant is non-zero. If this determinant of a square matrix is non-zero, then it's called non-singular matrix. If A is equal to 4 minus 7 5 minus 3, then what is the determinant of this? AD minus BC minus 12 plus minus of minus plus 35, it is 23, which is non-zero. Therefore A is a non-singular matrix. Second example, if A is equal to 1 2 1 3 2 2 1 1 5 1 1 2, already we have calculated its determinant is minus 5. So with the help of first row, 1 into 4 minus 2 minus 2 into 6 minus 2 plus 1 into 3 minus 2, this is minus 5. Therefore which is non-zero, therefore A is a non-singular matrix. Now unit matrix is also a non-singular matrix because its determinant is 1. Now all unit matrices of all orders, order 1, 2, 3, 4, 5, all our determinants are 1. Those all matrices are non-singular matrices. Adjoint of a matrix. Adjoint of a matrix is based on the cofactor matrix. See, first cofactor matrix. Cofactor matrix is a matrix which is obtained by replacing their elements with their corresponding cofactors. Cofactor matrix is it is a matrix obtained by replacing the elements of a matrix with their corresponding cofactors. Now, adjoint of a matrix. Adjoint of a matrix is a transpose of this cofactor matrix. So the transpose of the cofactor matrix of a matrix A is called the adjoint of matrix A, and it is denoted by adj of A or adjoint of A, or the transpose of a matrix, that matrix is a cofactor matrix, formed by replacing the elements of A with their corresponding cofactors is called the adjoint of matrix A. It is denoted by adj of A or adjoint of A. Hence, adjoint of A is cofactor matrix transpose. That is, if A is equal to A1, B1, C1, A2, B2, C2, A3, B3, C3, then cofactor matrix of A is capital A1, capital B1, capital C1, capital A2, capital B2, capital C2, capital A3, capital B3, capital C3, where this capital A1 is the cofactor of small a1, capital B1 is the cofactor of small b1, capital C1 is the cofactor of small c1, capital A2 is the cofactor of small a2, capital B2 is the cofactor of small b2, capital C2 is the cofactor of small c2, and capital A3 is the cofactor of small a3, capital B3 is the cofactor of small b3, capital C3 is the cofactor of small c3. Then adjoint of A is equal to cofactor transpose. That is A1, B1, C1, A2, B2, C2, A3, B3, C3 transpose. That equal to A1, B1, C1, A2, B2, C2, A3, B3, C3. This is the transpose adjoint of the given matrix, where capital letters are adjoints of the cofactors of the small letters. Now, the properties of this. Note: if A is of order 3 by 3, then adjoint of Ka is equal to K square adjoint of A, where K is a scalar. See, actually it is the property that is, if A is a matrix of nth order, then adjoint of Ka is K power n minus 1 into adjoint of A, where K is a constant. In n is 3, therefore K square into adjoint of A. If A and B are two non-singular matrices of the same order, then adjoint of AB is equal to adjoint of BA, adjoint of B into adjoint of A. It's a reversal order. Same as it is the property of the transpose of AB whole transpose is B transpose into A transpose. Now, adjoint of unit matrix is itself. Not only unit matrix, null matrix also itself. Now, if A is A, B, C, D, then adjoint of A is D minus B minus C, A. This is the adjoint of A. Now, if A is equal to A 0 0, B 0 B 0 0 0 C, that is the diagonal matrix, then adjoint of A is BC 0 0 0 CA 0 0 0 AB. It is also a diagonal matrix. The diagonal elements are replaced by its corresponding cofactors. A cofactor is BC, B cofactor is CA, C cofactor is AB. So these are the some of the note points that are the or properties. Now examples. Find the adjoint of A is equal to adjoint of the matrix A 1 2 1 3 2 3 1 1 2. So here first given that A is equal to 1 2 1 3 2 3 1 1 2. For finding the cofactors, here we have to find the for finding the adjoint of matrix A is we can find the cofactors. Sorry, cofactor of a matrix A is this cofactor matrix is a matrix which is obtained by replacing the elements of A with their corresponding cofactors. Here, what is a cofactor of A? Cofactor of A is minus 1 power 1 plus 1 because first element is 1, that is first row and first column, minus 1 power 1 plus 1 into determinant of the matrix which is obtained by deleting the row and column, first row and first column. So the determinant of the first row and first column, after elimination of the first row and first column, the matrix is 2 3 1 2. As a determinant is by using AD minus BC, that equal to 4 minus 3. So the cofactor multipliers. Cofactors are first one is plus and the one is next minus plus minus plus minus plus minus plus. So it come by alternative. So the second element is minus. Its minor is the determinant of the matrix which is obtained by deleting first row and second column. The determinant is matrix is 3 3 1 2. Its determinant is 6 minus 3. And for the last element of the first row, that is cofactor of 1 is this sign is plus and the determinant of the matrix which is obtained by deleting first row and third column, the matrix is 3 2 1 1. Its determinant is AD minus BC 3 minus 2. And the next minus second or first element is minus the determinant of the matrix which is obtained by deleting second row and first column, that matrix is 1 2 2 1 1 2. Its determinant is AD minus BC 4 minus 1. Now the second element of the second row, the determinant of the matrix 1 1 1 2, that is 2 minus 1. And the second row third element, that is minus after deleting the second or third column 1 2 1 1 2 1 1. Its determinant is 1 minus 2. And the third row first element, the minor is after deleting third row first row third column, sorry, third row first column. Its determinant is 2 1 1 3 2 1 2 3. So determinant is 6 minus 2. Next minus the after deleting third row second column 1 1 3 3. So determinant is 3 minus 3. And the last row last column element, after deleting this, the matrix is 1 2 3 2. So determinant is 2 minus 6. Now after simplifying this 1 minus 3 1 minus 3 1 1 4 0 minus 4. Now the adjoint of A is cofactor transpose. That cofactor is 1 minus 3 1 minus 3 1 1 4 0 minus 1 4. So transpose means by interchanging rows and columns. 1 minus 3 4 minus 3 1 0 1 1 minus 4. This is the required adjoint of the given matrix. Now the second example, find the adjoint of the matrix capital A. Capital A is equal to 1 minus 1 1 2 3 minus 3 6 minus 2 minus 1. Here first we will find the cofactor matrix of this matrix. Cofactor is first given that A is equal to 1 minus 1 1 2 3 minus 3 6 minus 2 minus 1. Now cofactor of the matrix A is equal to cofactor matrix of A is equal to the elements are replaced by their corresponding cofactors. In this cofactors plus minus alternative. Now cofactor of 1 is the determinant of the matrix after deleting first and first column. The matrix is 3 minus 3 minus 2 minus 1. Its determinant is minus 3 minus 6. The second element is minus. By deleting first row and second column, the matrix is 2 minus 3 6 minus 1. Its determinant is minus 3 plus 18 minus 2 plus 18. Next element is plus. third row, first column, first row, third column element. After deleting this, the matrix is 2 3 6 minus 2. Its determinant is minus 4 minus 18. Now second row elements, second row first column. After deleting second row first column, minus 1 1 minus 2 minus 1. Its determinant is 1 plus 2. Second next element, second row second column element. By deleting second row and second column, matrix is 1 1 6 minus 1. Its determinant is minus 6 minus 1. Next, minus second or third column. The matrix is 1 minus 1 6 minus 2. Its determinant is minus 2 plus 6. And the third row elements, third row first column. After deleting third row first column, the matrix is minus 1 1 3 minus 3. Its determinant is 3 minus 3. Next, minus uh, after deleting third row second column, 1 1 2 minus 3. Its determinant is minus 3 minus 2. Next, last element, third row third column element. After deleting third row third column, 1 minus 1 2 3. So determinant is 3 minus of minus plus 2 3 plus 2. Now after simplifying this, you can get minus 9 minus 16 minus 22 minus 3 minus 7 minus 4 0 5 5. Now adjoint of this matrix is the cofactor matrix transpose. The transpose of minus 9 minus 16 minus 22 minus 3 minus 7 minus 4 0 5 5. That's power t. That is minus 9 minus 3 0 minus 16 minus 7 5 minus 22 minus 4 0. This is the required adjoint of the given matrix. Now third example, find the adjoint of the matrix A is equal to 2 minus 2 4 2 3 2 minus 1 1 minus 3. Given that A is equal to 2 minus 2 4 2 3 2 minus 1 1 minus 1. Now the cofactor matrix of A, that cofactor elements are cofactor of 2 is, after deleting first row and first column, the matrix is 3 2 1 minus 1. Its determinant is minus 3 minus 2. Second, minus after deleting first row and second column, 2 2 minus 1 minus 1. Its determinant is minus 2 plus 2. Next, plus element, that is after deleting first row and third column, 2 3 minus 1 1. Its determinant is 2 plus 3. Now second row elements, that is minus after deleting second row first column, minus 2 4 1 minus 1. So determinant is 2 minus 4. Next, second row second column element, it is plus after deleting second row and second column, 2 4 minus 1 minus 1. Its determinant is minus 2 plus 4. And second row last element, cofactor of 2 is, after deleting second row and third column, the matrix is 2 minus 2 minus 1 1. Its determinant is 2 minus 2, sorry, right, 2 minus 2. Now the determinant cofactor of minus 1, that is third row first column. After deleting third row first column, minus 2 4 3 2. Its determinant is minus 4 minus 6 minus 12. Now next element is minus minus after deleting second third row second column, 2 4 2 2. As the determinant is 4 minus 8. The last element, that is third row third column. After deleting third row third column, 2 minus 2 2 3 6 minus of minus plus 6 plus 4. Now simplifying these elements, that is minus 3 minus 2 minus 5, minus 2 plus 2 0, 2 plus 3 5, minus minus of 2 minus 4 just 2, minus 2 plus 4 2, minus 2 plus 2 0, minus 4 minus 12 minus 16, minus of minus 4 plus 4, 4 plus 6 10. This is the cofactor matrix of A. Now the adjoint of A is cofactor transpose, that is minus 5 0 5 2 2 0 minus 16 4 10. It's a transpose, that will get minus 5 2 minus 16 0 2 4 5 0 10. This is the required adjoint of the given matrix. Now next, Find the adjoint of the matrix A is equal to minus 4 minus 3 minus 3 101 443. Now given that A is equal to minus 4 minus 3 minus 3 101 443. Now we have to find the cofactor matrix of A. Cofactor matrix of A is by replacing the elements with their corresponding cofactors. And that the first cofactor of minus 4 is the first row first column. After deleting first row and first column, the matrix is 0 1 4 3. As the determinant is 0 minus 4. Next element is minus because as the cofactor sign minus. After deleting first row and second column 1 1 4 3. As the determinant is 3 AD minus BC 3 minus 4. Now the last element of the first row, that is cofactor of minus 3. After deleting first and third column 1044, as the determinant is 4 minus 0. Next row, second row elements, first element is minus. After deleting second row first column, the matrix is minus 3 4 3, as the determinant is minus 9 plus 12. Next element is plus. So after deleting second row and second column, the matrix is minus 4 minus 3 4 12, as the determinant is minus 12 plus 12. Next second row last element, that is after deleting second row third column minus 4 minus 3 4 4 minus 16 plus 12. Now the last row elements, cofactor of 4 after deleting first column third row minus 3 minus 3 0 1, its determinant is minus 3 plus 0. Next negative sign minus of after deleting third row second column minus 4 minus 3 1 1, its determinant is minus 4 plus 3. Now the last element, last row last column, after deleting last row last column, that is third row third column, minus 4 minus 3 1 0. Its determinant is 0 0 plus 3. After simplifying, 0 minus 4 is minus 4, minus of 3 minus 4 is plus 1, 4 minus 0 is 4, minus 9 plus 12 minus 3 minus 3, minus 12 plus 12 is 0, minus of minus 16 plus 12 is plus 4, minus 3 minus 0 minus 3, minus of minus 1 plus 1, it is 3, 3 plus 0 3. Now we have to find the adjoint matrix. Adjoint of A is as a transpose of the cofactor, that equal to minus 4 1 4 minus 3 0 4 minus 3 1 3. It's a transpose, that will get minus 4 minus 3 minus 3 101 443. Once you observe, this matrix is same with the given matrix A. Here this matrix is the self-adjoint. Already we have seen some self-adjoint matrices that are unit matrix and the one is null matrix. These two are the self-adjoint anywhere, but this is also one of the example for this self-adjoint, that is minus 4 minus 3 minus 3 101 443. This is the one of the self-adjoint matrix. Now example 5. Find the adjoint of the matrix capital A is equal to 1 2 minus 2 minus 1 3 0 0 minus 2 1. Now for this one is given that A is equal to uh, A equal to 1 2 minus 2 minus 1 3 0 0 minus 2 1. Now it's cofactor matrix. Cofactor matrix of A is equal to, directly cofactors I'm taking, cofactor of the first element. After deleting first row and first column, the matrix is 3 0 minus 2 1. Its determinant is AD minus BC 3 minus 0. Next minus of second row, first row second element. After deleting first row second column, minus 1 0 0 1. Its determinant is AD minus BC minus 1 minus 0. The next plus, and this is after deleting the first row and third column, AD minus BC 2 minus 0. The second row elements, after deleting second row first column, 2 minus 2 minus 2 1, AD minus BC 2 minus 4. Next plus, After deleting second and second column, 1 minus 2 0 1, its determinant is 1 minus 0. Second or last element, like second or third column. After deleting the second and third column, 1 2 0 minus 2, so determinant is minus 2 minus 0. Next, the third elements cofactor of 0 is the first one, third row and first column. After deleting this, the matrix is 2 minus 2 3 0. As determinant is 2 minus 0, 0 minus of minus 6 means 0 plus 6. Next, cofactor of third row second column element, that is minus 2, that is after deleting third row second column, matrix is 1 minus 2 minus 0. Its determinant is 0 minus of minus 2, 0 minus 2. And the cofactor of the last element, that is third row third column element, 1. After deleting third row third column, we can get a matrix 1 2 minus 1 3. Its determinant is 3 minus plus minus of minus 2, that is plus 2. Now after simplifying this, 3 minus 0 is 3, minus of minus 1 1, plus 2 minus 0, minus of minus 2 2, 1 minus 0 1, minus of minus 2 2, 6, minus of minus 2 2, 3 plus 6 5. This is 3 1 2 2 1 2 6 2 5. This is the cofactor matrix of A. Now we have to find the adjoint of A. Adjoint of A is cofactor matrix transpose. It's a transpose. That is 3 1 2 2 1 1 2 1 2 6 2 5. It's a transpose is 3 2 6 1 1 2 2 2 5. This is the required adjoint of the given matrix A. Now we have to take the next example. It is if A is equal to 2 minus 1 6, 2 minus 1 4, x 0 1, 1 2 0 is a singular matrix, then find the value of x. Given that A is equal to 2 minus 1 4, x 0 1, 1 2 0 is a singular matrix. If it is a singular matrix, then its determinant is 0. So mod 2 minus 1 4 x minus x 0 1 1 2 0 is 0. So by expanding with the help of first row, 2 into 0 minus 2 minus of minus 1 plus 1 into 0 into x ad minus this is 0 minus 1 plus 4 into uh, x 0 1 2, as the determinant is 2x minus 0 equal to 0. From this relation, minus 4 minus 1 plus 8x equal to 0. 8x equal to 5, x equal to 5 by 8. This is the value of x. Similarly, one more problem. Find the value of x if 2 3 5 2x 5 3 minus 1 2 is a singular matrix. See, this problem they can ask in another way. Find the value of x if the determinant of this matrix is 0. So given that A, let us take this matrix as A. Given that A is a singular matrix, so it is a determinant is 0. Given that A is a singular, so that its a determinant is 0. Therefore, by expanding with the help of first row, 2 into determinant of x 5 minus 1 2 minus 3 into determinant of 2 5 3 2 plus 5 into determinant of 2 2 8, here one spelling typical mistake. Instead of x, I have typed as 8. 8 is wrong. 2x 3 minus 1 equal to 0. By expanding this, 2 into 2x plus 5 minus 3 into 4 minus 15 plus 5 into minus 2 into minus 2 minus 3x equal to 0. After simplification, 4x plus 10 minus 12 plus 6 minus 12 plus 15. Actually, it is better to write minus 33, but I have written plus 33. Okay, right, no problem. Minus 10 minus 15 x equal to 0. Here how many x are there? Plus 4 minus 15 minus 11x. Constant term is 33 equal to 0. Then x equal to minus 33 by minus 11, that is 3. So the value of x is 3. Now we have to go to the next problem, summary. In this we have discussed the singular matrix. Singular matrix is a square matrix capital A is said to be singular if its determinant is 0. Next, non-singular matrix. A square matrix is said to be non-singular if its determinant is non-zero. So, adjoint of a matrix. Adjoint of a matrix is the transpose of a matrix which is obtained by replacing the elements with their corresponding cofactors. That means the transpose of a cofactor matrix. Now, a quiz. Quiz is, which one of the following matrix is a non-singular? Non-singular means its a determinant is non-zero. First, A option. If you observe A option, it is a null matrix. All elements are zero, so its a determinant is automatically zero. Or if you are interested, you can find 0 into something minus 0 into something plus 0 into something with the help of first row, and the total value is 0. Next, 1 0 0 0 1 0 0 0 1. If you find its determinant, 1 into AD minus BC, 1 into 1 minus 0, minus 0 into something plus 0 into something. So it is 1 into 1, 1. So its a determinant is 1, which is non-zero. It is a non-singular matrix. What about third one? 1 2 3 4 5 6 7 8 9. If you find its determinant with the help of first row, 1 into 45 minus 48 minus 2 into 36 minus 42 plus 3 into 32 minus 35. So if you simplify this, it will become 0. D is none of the above. See, actually, here B matrix is a non-singular matrix. Remaining two are singular matrix. So correct option is B. Correct option is B. Now second one, if A equal to A 0 0 0 B 0 0 0 C, then adjoint of A. Adjoint of a diagonal matrix is the diagonal matrix whose diagonal elements are replaced by their corresponding cofactors. A cofactor is BC, B cofactor is CA, C cofactor is AB. So if you find that A is the same matrix, it's not a self adjoint, it's the wrong option. 1 by A 1 by A 0 0 0 1 by B 0 0 0 1 by C, it is not a adjoint matrix. This actually will come later. It is a inverse of the matrix, also we'll discuss in the next class, but it is not an adjoint. BC 0 0 CA 0 CA 0 0 0 AB, this is the adjoint, required adjoint. None of these, so the correct option is C is the correct option, right? This already we have discussed. If A is in order 3 by 3 and K is any scalar, then what is adjoint of Ka? Here adjoint of Ka is order with the help of nth order, K power n minus 1 into adjoint of A. Here n is 3, so K square into adjoint of A. So first option is K into adjoint of A, it is wrong option. K square into adjoint of A is our correct option. Third one is the K cube into adjoint of A, it is the wrong option. None of these. So correct option is B is the correct option. Now some of the assignment problems. These assignment problems are, if A is equal to 1 2 3 4 5 6 7 8 x is a singular matrix, find the value of x. Just now we have seen one of the problem. That problem is find the determinant of 1 2 3 4 5 6 7 8 9. Its determinant is 0 if it is x is replaced by 9. So you can take the determinant of this matrix is equal to 0. By simplifying that, you can get x equal to 9. Second problem is find the adjoint of A matrix. Adjoint of the matrix A equal to 0 8 2 3 9 5 6 0 6. Now for this, adjoint of A is the transpose of the cofactor matrix. If you find the cofactors, cofactor of 0 is 54 minus 0 minus 18 minus 30 plus 2 in 2, cofactor of 2 is 0 minus 54. The second row elements are minus 48 minus 0. Second element is 0 minus 12. The third element is minus 0 minus 48. The last row elements are 48 minus 18, that is a minus term, plus 0 minus 6, mine sorry, it is plus term. Last term is a plus, before term is a minus, plus 0 minus 24. By transpose of this you can get it adjoint. Next, find the adjoint of adjoint of the matrix capital is equal to cos theta sin theta 0 minus sin theta cos theta 0 0 0 1. In this case, if you observe, the cofactor of cos theta is cos theta. Next, minus cofactor of minus sin theta is cofactor of sin theta is minus sin theta, so it is plus sin theta. Cofactor of 0 is AD minus BC cos square minus sin plus sin square, that is 1. And the second row elements, cofactor of minus sin theta is actually it is minus term. Cofactor of second row elements sin theta minus 0, that is minus. Next, second midterm, cofactor of cos theta, that is cos theta minus 0. And the last second or last element cos square plus sin it is 0, AD minus BC after deleting that. Now the last row elements after deleting first row, last row first column, it is also 0. And the second element of last row, this one also after 0. And the last element cofactor is cos square plus sin square, it is also 1. Now after finding its transpose, you can get its adjoint. I think this may be coincide once you discuss what is the result. Is it self-adjoint or not? Once you discuss, means just find the adjoint of the matrix. So it may be coincide or may not, self-adjoint or not. The next one is find the adjoint of the matrix 2 1 3 3 1 2 1 2 3, and also show that add A into adjoint A is equal to adjoint A into A is equal to determinant of A into I. Means here first we find adjoint of A by transpose of the cofactor matrix. After getting that matrix, multiply with the given matrix as a pre-multiplier and post-multiplier. Both will get as a diagonal matrix whose diagonal elements are the determinant. Once you cross check and that diagonal elements are you can take outside, then it will become I. So this is actually it's a lengthy problem. Means we have to find adjoint matrix and pre-multiply with A and post-multiply with A, and what is the determinant of that A, and then you can conclude the given result. Okay. Now the previous exams questions, find the adjoint of A. A is equal to 082395606. Second problem is 1 minus 1 1 3 9 minus 3 6 minus 2 minus 1, and 1 0 2 3 4 5 2 3 1. These are the some of the problems. Now once we recall what we have learned today, So this is just a outlook we have to recall. Now today we have discussed singular matrix and non-singular matrix. What is a singular matrix? What is the singular matrix? Singular matrix is here. Singular matrix is a square matrix capital A is said to be singular if its determinant is 0. The process of to evaluation of determinant, if it is a square 2 by 2 square matrix, then its determinant is AD minus BC. If it is not a square 2 by 2 matrix, if it is a third order and higher order, its determinant is defined as sum of the products of any row or any column with their corresponding cofactors. With the help of that, you can find the determinant of the square matrix. If it is 2 by 2, you can find directly AD minus BC. If it is 3 by 3, with the help of first row or first second row or third row or first column, second column, third column, we can find its corresponding determinant. So with the help of that determinant, if the determinant is 0, then that matrix is singular matrix. If the determinant is non-zero, then that is a non-singular matrix. Second one is non-singular matrix. Non-singular matrix means a square matrix capital A is said to be non-singular if its a determinant is non-zero. That is, if the determinant of a matrix is non-zero, then it is called non-singular matrix. So already we have seen some of the examples. If the determinant of this matrix is non-zero, then it is a non-singular matrix. One 3 by 3 matrix also we have checked. Already this determinant we have calculated previously. As the determinant is minus 5, so it is a non-singular matrix. Minus 5 is non-zero, so non-singular matrix. Now one note point is every unit matrix is a non-singular because as a determinant is its determinant is 1, that is non-zero. Now adjoint of a matrix is based on the cofactor matrix. If the cofactor matrix is the matrix which is obtained by replacing the elements of A by its corresponding cofactors. So here the cofactor matrix is, it is a matrix obtained by replacing the elements of the matrix with the corresponding cofactors. Now adjoint of a matrix. Adjoint of a matrix is the transpose of the cofactor matrix. The transpose of the cofactor matrix of A is called the adjoint of the matrix and is denoted by adjoint of A and adjoint of A, ADJ of A. Or this definition you can write it as the transpose of the matrix. That matrix is cofactor matrix within the bracket because the matrix formed by replacing the elements of the matrix A with their corresponding cofactors is called adjoint of the matrix A. It is denoted by adjoint of A or adjoint of A. Already we have discussed, and that is hence adjoint of A is a cofactor matrix of A. And just recall one problem, not all the problems. So how to find the adjoint of A? Before that, this is also one of the important concept. If A is A1 B1 C1, A2 B2 C2, A3 B3 C3, then its cofactors are capital letters. Cofactors of the small elements are denoted by capital letters. Then cofactor matrix is A1 B1 C1, A2 B2 C2, A3 B3 C3. It's a transpose is the adjoint. Adjoint of A is the transpose of the cofactor, that is transpose of A1 B1 C1, A2 B2 C2, A3 B3 C3. That is A1 A2 B A3 B1 B2 B3 C1 C2 C3 is the adjoint of the given matrix. Now we'll discuss one note point. That note points are, if A is an of order 3 by 3, actually if it is of order n by n, then adjoint of Ka is k power n minus 1 into adjoint of A, where k is a scalar. If A is an of order 3 by 3, then the adjoint of Ka is k square into adjoint of A, where A is constant. Second property, already we have I have given one problem based on this. If A and B are A and B are two non-singular matrices of the same order, then adjoint of AB is equal to adjoint of B into adjoint of A. It's a reversal property. like AB whole transpose is B transpose into A transpose. He also same. A adjoint of AB is adjoint of B into adjoint of A. Next, third property, adjoint of unit matrix is itself. Not only unit matrix, null matrix also same self adjoint. If A is ABCD, then its adjoint is A and D are interchanged, minus B minus C, D minus B minus C A, it is an adjoint. If A is diagonal matrix where diagonal elements of ABC, that is A00 or 0B0 0 0C, then its adjoint is BC 0 0 0 CA 0 0 Here it is also a diagonal matrix whose diagonal elements are replaced by its corresponding cofactors. That cofactors are, for diagonal matrix it's very simple to evaluate the cofactors. Just AD minus BC is enough. Now one example we'll discuss, then we'll close this session. Find the adjoint of the matrix capital A. One, given that A is equal to 1 2 1, 3 2 3 1 1 2. Now the cofactor matrix of A is equal to, these elements are replaced by the corresponding cofactors. 4 minus 3, it's a cofactor of 1. Cofactor means minus 1 power I plus j into minor of the element. That minor of the element is minor of the element of ith row and jth column is the determinant of the matrix which is obtained by deleting ith row and jth column. So here the cofactor of the first element is, by deleting first row and first column we can obtain a matrix that is 2 3 1 2. Its determinant is AD minus BC 4 minus 3. So minus, the next element is minus. Second element is determinant of the matrix 3 3 1 2. So its a determinant is 6 minus 3. The third element of the first row is determinant of the matrix 3 2 1 1 3 minus 2. Second row elements minus the determinant of the matrix after deleting second row first column 2 1 1 2. Its a determinant is 4 minus 1. Second row second element after deleting second row second column 1 1 1 2. Its a determinant is 2 minus 1. And the last element of the second row after deleting second row third column 1 2 1 1. Its determinant is 1 minus 2. And the third row elements after deleting third row first column 2 1 2 3. So determinant is 6 minus 2. And second element of the third row, it is minus after deleting third row second column 1 1 3 3 with the help of AD minus BC. Its determinant is 3 minus 3. Now the third row third column element, it is a plus element after deleting third row third column 1 2 3 2. Its determinant is 2 minus 6. After simplifying this, 3 minus 4 minus 3 is 1, minus 3 1, minus 3 1 1 4 0 minus 4. Now adjoint of this matrix is cofactor matrix transpose. The transpose of this matrix 1 minus 3 1 minus 3 1 1 4 0 minus 4. Its transpose is 1 minus 3 4 minus 3 1 0 1 1 minus 4 is the required adjoint of the given matrix. Now similarly you can find the remaining problems, and one different problem, that is to find uh, the x value if the given matrix is the singular matrix. Here we'll discuss one problem for that, then we'll stop the session. Okay, so this is, if the given matrix, if A is equal to 2 minus 1 4 x 0 1 1 2 0 is a singular matrix, then find the value of x. Here singular means the determinant of A is 0. Find the value of x. Given that A is equal to 2 minus 1 4 x 0 1 1 to 0. Since A is a singular matrix, then determinant of A is 0. That is determinant of 2 minus 1, 4, x 0 1 1 2 0 is equal to 0. Therefore, by expanding this determinant with the help of first row, 2 into 0 minus 2 plus 1 into 0 minus 1 minus plus 4 into 2x minus 0, that equal to minus 4 minus 1 plus 8x equal to 0. This is 8x minus 5 plus 8x equal to 0, 8x equal to 5, x equal to 5 by 8. This is the uh, value of x. Now, once we reach a singular matrix, that is the determinant of A is 0. Non-singular matrix, determinant of A is non-zero. And adjoint of the matrix. Adjoint of the matrix is transpose of the cofactor matrix. Cofactor matrix means cofactor matrix, the elements are replaced by its corresponding cofactors. So, this is the today class. Shall we stop this?